My name is Djuna Gulliver. I am a research scientist at National Energy Technology Laboratory for the Department of Energy here in Pittsburgh, Pennsylvania. So I have a couple of responsibilities. Right now, I have responsibilities to do my research. So I'm a microbiologist. So what I do is I get samples from different environments, such as soil, rocks from the subsurface or from underground, and then I extract the DNA from it, and I take a look at what the microbiology is in these systems. And then I also kind of oversee projects. So I have other researchers that do very similar things, or they look at the geochemistry, and then I make sure that all of that science comes together for an overall project. When I graduated from high school, I was really interested in something that was very applied. So I majored in chemical engineering, but I always kind of had this bug to learn geology as well. So I also majored in geology. So in undergrad, I got a chemical engineering and geology degree. I decided I would go back for my master's degree, and I got a master's degree in environmental engineering, which kind of seemed to meld all of those specialties together, chemical engineering and geology and microbiology. And then after my master's, I felt I wasn't done learning about the field, so I went on to get a PhD in environmental engineering. So mentors, I had mentors here and there. I had a really great professor I worked with in undergraduate jobs, and she really helped me kind of decide what types of universities to apply for if I was interested in graduate school, and she was very encouraging. When I was in my master's degree, there was also another woman who really encouraged me to apply around for my PhD. And then I also did a lot of work for Engineers Without Borders in South Africa, and the professor I worked with that also, he was very encouraging to continue research. And then from there, my advisors would be my mentors. They kind of you almost get like this weird family relationship with your advisors after a while. So I would say that they were my mentors afterwards for my PhD. My parents have an interest in science as well, and so when I was really little, they had the Science Museum of Minnesota, because I'm from Minnesota, had all of these little day camps you could go to, and it was only a day long. And one of the camps that my parents always sent me to was it was called Fossil Camp. And actually, all we did was that all of us kids just boarded on a bus, and I was maybe 5 or 7, and we drove to someplace north of Minneapolis, and we were just walking around on these rock formations around there, and then we would look for fossils. And actually there were a ton of fossils that you could find just by walking around in these areas, and and so we were just pulling rocks and putting them in our backpacks, and then at the end of the day we'd have all of these fossils. The fossils weren't too exciting when you look at them as an adult. They were little things that looked like Cheerios, that were just the bases of stems of different ancient creatures, and little clamshells and things like that. But still, it was fun, and obviously something stuck with me about that geology. Grade school, we'll say, and middle school, we had this weird thing called high potential. And it was where they take these grade school kids and they test them to see if they have high potential, to be very successful in the future. And actually, I was not high potential. So I took that test and I guess I bombed it, you could say, which is very discouraging. My teacher of my 6th grade math class said that I had a lot of potential to be good at math. And she really encouraged me, because even though as a young child I wasn't separated as being one of those really gifted students, she still saw a lot of potential in me and still really pushed me towards the STEMs. really huge. The field of microbiology has expanded so much from even just the year 2000. For example, I do a lot of DNA sequencing. So you can imagine how small of quantities I'm dealing with. And DNA is so small, but we have the technology to basically tell you exactly what the whole entire sequence is in these environmental samples. From there, also, you can imagine the amount of data that you get. And there's a huge field now in computer programming just for DNA sequencing, because you get all of this data, you have to analyze all of this data, and it's called bioinformatics, and it's all about figuring out how to code different projects, how to code different DNA sequences for these projects, and you have to stay up to date with all of the newest technology to sequence your DNA and all of the newest computer programs to make sure that you're analyzing them correctly. For students, I think that it's just important to make sure that they aren't intimidated by these particular subjects. I think it's easy to be like, oh, I'm not interested in that, or oh, that's for smart people, and I think it's just you learn it. It's not like I was particularly science driven more than average, or I was particularly smarter than other kids, or more math inclined than other kids. It was just that I just continued my training to learn it. And I think that if students realize that you just have to be trained in it, and then you could also be a scientist.